To see how RMS, or root mean square, fits into our real power calculations, let's take a look again at what our definition of RMS is. And so that would be the magnitude of the voltage divided by the square root of 2, and the magnitude of the current function divided by square root of 2. And if we substitute both of these values into our previous average power expression, then what ends up happening is actually those two square root of 2 components multiply together and then cancel with the 1/2 that's embedded in that equation. And so we end up just simply reducing this down to VRMS IRMS times the cosine of the two phases. So this is an equivalent expression. If I have the magnitude of some sort of wave, I can calculate the real power. Or if I have the RMS values, I can calculate the same real power. And so these two expressions are interchangeable due to this relationship right here, and you might see it expressed in a variety of formats. But it's really, really important to get your notation correct to make sure you know if you're dealing with the real value of something. So again, if I have some wave that is oscillating through time, this value right here is going to be Vm or Im, and we can go ahead and calculate RMS from that by dividing by square root of 2. But make sure you know that Vm is something that you'd sort of measure from an oscilloscope. It would give you the voltages over time. VRMS, I mean, you could again measure, but it's not going to be directly obvious. But it might be given to you as a problem, as many sort of circuits are referenced in terms of their RMS values, which are their effective DC values.